Hello viewers, Electric Circuits question 9. For this circuit, find the total resistance and the current through the battery and each resistor. Therefore, find the power output of the battery and the power consumed by each resistor. So we have a 6-volt battery and we have 4 resistors in our circuit. So let's follow the paths that a possible electron can take around the circuit. So one path is going to be from the battery through this 1.1 ohm resistor, through this 2 ohm resistor, through that 2 ohm resistor, and back to the battery. The other possible path is the larger loop, 6-volt battery, 1.1 ohm resistor to this 1 ohm resistor, and then through this 2 ohm resistor. So what we see there is that either way, whichever path an electron takes, it's going to go through the 1.1 ohm resistor and the 2 ohm resistor. So these two resistors are in series, whereas this 2 ohm resistor and the 1 ohm resistor are in parallel with each other. So therefore, let's find the total resistance of the circuit, which is going to be the total resistance is this 2 series resistors will be 2 plus 1.1. They're in series, so we can add those. And for the 2 parallel resistors, we've got 2 to the power of -1 plus 1 to the -1, all of that to the -1. So we've got 3.1 here. This part works out to be 0.6666, so we end up with an overall resistance of the circuit of 3.766 ohms. So there we've got the total resistance of the circuit. Now we need to find the common current, so the current through the battery, which will be the same as the current through this series 2 ohm resistor and the 1.1 ohm resistor. So the common current is obtained by Ohm's law of V over R, which is 6 divided by 3.766, and if we calculate that, we end up with 1.593 amperes. So that's the current through the battery. Now we need to find what the voltage through the parallel part of the circuit is, and in order to get that, we'll need to work out the voltage across the 2 series resistors. So let's look at the voltage of the 1.1 ohm resistor, which is obtained by Ohm's law, V equals IR. Current through it is going to be 1.593, and its resistance is 1.1. If we calculate that, we get 1.75 volts. And we also need the voltage through the 2 ohm resistor. So the voltage across the 2 ohm resistor is going to be, again, I times R, which is 1.593 multiplied by its resistance, which is 2, and that gives us 3.19 volts. So therefore, for the parallel 2 resistors, which means this 2 ohm resistor and that 1 ohm resistor, is going to be equal to 6 ohms, which is 6 volts, which is the voltage across the battery, minus 1.75 minus 3.19, and that gives us an answer of 1.06 volts. So that's the voltage across the 2 resistors that are in parallel. So now we need to we know what the current across these 2 resistors are. The current going through those 2 resistors is both 1.593 amps. Now let's work out the current through the parallel 2 ohm resistor and the 1 ohm resistor. So the current going through the 2 ohm resistor, which is in parallel, is going to be V over R. The voltage across that resistor is, it's looking at the parallel part of the circuit now, so it's 1.06, and we're dividing that by 2 because it's a resistance of 2 ohms, and that gives us 0.53, and that will be in amps there. Now we need to find the current across the 1 ohm resistor, which is V over R, which is 1.06 divided by 1, which is 1.06 amps. And if we add these two currents, 0.53 plus 1.06, we get 1.59, which is, to within round off, the common current. So 1.59 amps through the common part of the circuit. 0.53 of an amp goes through this pathway, and through the 1 ohm resistor, the remaining 1.06 amps. Okay, so now we know the current across each resistor. Let's work out the power. So the power of the battery, power is current times voltage, and the current of the battery is 1.593 times the voltage of the battery was 6 volts, and that gives us 9.558 watts. So the power of the 4 resistors should add up to 9.558 watts, at least to within round off error. Okay, so let's work out the power of the 1.1 ohm resistor, which is I times V, and the current there is 1.593 multiplied by the voltage across it we worked out before to be 1.75, and if we calculate that we get 2.79 watts. Let's then work out the power across the 2 ohm series resistor, which is I times V. Now the current was 1.593, and we're multiplying it by that voltage, which is 3.19, and if we calculate that we get 5.08 watts. So that is going to be the resistor that uses up most of the power. Now let's work out the 2 ohm parallel resistor, which is I times V. For that 2 ohm parallel resistor, the voltage we know to be 1.06 volts because we're looking at one of the parallel resistors, and the current across it for the 2 ohm we found to be 0.53, and if we calculate that we've got 0.53 times 1.06, and that gives us 0.56 watts. So now we've got one remaining resistor, which is the 1 ohm resistor. I times V is, the current was 1.06 multiplied by 1.06, and that gives us 1.12 watts. Okay, so does the power add up as we expect? So if we add up these, we've got 2.79 plus 5.08, which is 7.87, plus 0.56 is 8.43, plus 1.12 is 9.55. So that's 9.558 watts to within round off error. Thanks for watching. Over and out.